All right, so we're almost at the end of Chapter 9, Part A. We've spent all this time, all those videos, to get to the end here. I wanted to make this separate from your basic standard percent composition. This is percent composition, except we're going to go backwards. That's our objective for this video. Okay? So what if you have the percent by mass of the different elements? How do you figure the empirical formula? Well, first thing about it is you have to assume 100 grams of the sample. Why? Because it's a whole lot easier to work with it. If they say 60% carbon, 20% oxygen, 20% hydrogen, for example, those are percents, and we can easily translate those into versions of 100 grams, right? Because you take away the percent sign and put the grams there and boom. So if something is 60% carbon, we can say, hey, it's 60 grams of carbon and be done with it. It makes it a lot simpler when you have to go and figure that out. So then the next trick is to calculate how many moles of each. That's where we're gonna go from grams to moles, which means, ladies and gentlemen, that are we going to multiply? No, we are dividing. That's right, we are dividing. We are dividing, okay? So we can reduce the mole ratio of the lowest whole number ratio, no fractions or decimals. A lot of words, but the idea isn't that complicated. So let's switch to the next slide, because this thing only has 2 slides to worry about. Here, so I have an example here. I happen to have 75% carbon, 25% hydrogen. So they're asking us, what are the subscripts? That is the entire point of this video right here. What's in the subscripts? Well, we got percent compositions, which that's great, that's wonderful. So what we can do, let's change that over to grams, okay? So let's go ahead, and we're gonna assume 100 grams of the sample, right? So 75 grams, okay? And 25 grams of hydrogen, 75 grams of carbon. Okay, so that would be our first step that we have. We're trying to make this simple. Okay, I don't know how much simpler we can make it. So again, you take the percents, you change it to grams. Now, if it's 75.12, yes, it's, guess what? It's 75.12 grams. Exactly. Okay, so now, next trick. How many moles of each do we have? Well, remember, if we are going from grams to moles, we are going to divide. Now, of course, the question is, what are we dividing? Well, you'd have to divide what you have at the start over how many grams there are in a mole of something. That's the key formula there, ladies and gentlemen. That's it. Okay, some of you guys, you still kind of switch that around, so you have to be careful about this. Pay attention. Okay, so let's look at this. So 75 grams of carbon. How many grams of carbon are there in 1 mole? It's 12.01 grams per mole. When we look at hydrogen, it's 1.01 grams per mole. Mr. Canu! Yeah, Johnny. Where did you get that 12.01 and that 1.01? Johnny, not a problem. Those numbers come from the periodic chart. Okay? Really? Yeah, trust me on this one, Johnny. Okay, so now we've got that. Let's figure out how many moles of carbon do we have. So I'm going to take my handy dandy calculator right here and say 75 divided by 12.01, and I walk away with 6.244 moles. So I'm going to say 6.24 moles of carbon. Okay. Now, let's look at the hydrogen. The hydrogen is 25 divided by 1.01, and I walk away with 24.75 moles of hydrogen. So this is what we have here. So we started out here, we took our percent, changed it into grams. Then we divided it by grams per mole to find out the number. See, that's the key. When we start out with the mass, that doesn't make any sense. But remember, we can change the mass into numbers. And when we change that into numbers, how do we represent that? By individual atoms? No, we use the moles, remember? That's the point, because a mole is a number. It's that giant number. We don't use it in our everyday lives because it's too big, but in chemistry, it's perfect. Okay, so we got 6.24 moles of carbon, 24.75 moles of hydrogen. Now, what's the next thing? The next thing, guys, let's look on here. Reduce the mole ratio to the lowest whole number ratio, no fractions or decimals. Let's look at this here for a second. So, if I'm going to divide, so I'm going to take the smallest number, and I'm going to divide it by itself. Now, why would I do that? Because, ladies and gentlemen, I can make it into 1. Because you see, right now, let me erase this for a second. So, what do I exactly have here? If I wrote up my formula, it's going to be C6.24H24.75. That's what the formula looks like right now, because in this sample,